Hey everyone, and welcome to the second demonstration video for the tessim software. In the previous demonstration, we saw how we can use tessim in order to simulate a very simple system using to turn on and off the motor, which is reading a digital input on a microcontroller, which is Atmega. So for this demonstration, we have a similar system but slightly more complicated. So instead of a simple digital on or off input, we have an analog input, and that is connected to node number 96. That will be pin 97 of Atmega. And as you can see, the Atmega pin number 97 is ADC 0, which is the analog to digital pin number 0. So here we'll be applying our external input. Okay, so as expected, instead of the motor simply turning on or off, because earlier we had a digital signal, here we expect that as we vary the analog voltage, the motor should vary according to whatever the analog signal is applied. The motor speed should vary according to that. Okay, so the C code is, this is the C code. I'm not again going into much detail of this. It's essentially setting up the ports, the ADC, the PWM, and in this infinite loop it is just reading whatever is in the ADC, and it is reading that into the registers that define the duty cycle. So as you can guess, the duty cycle should be varying according to whatever is the value in the ADC registers. And this is the compiled binary file which can be uploaded on the target microcontroller here, and we'll also be using the same file for the purpose of a simulation. Okay, and this is how you can apply a sinusoidal force in tessim. This is the SRC is the source object, the sine source, this is the syntax. So frequency, this is actually the radial frequency, not the hertz frequency, it's in radian per seconds. We can apply that frequency, define the node to which that signal is applied, the amplitude of the signal, and if there is a DC offset. So mathematically this will be the signal that is applied in volts to that particular node, and that node is connected to pin 97, which is the ADC 0 pin of the Atmega. Okay, and we'll simulate the system for 5 seconds, for this much amount of time with these time divisions. Okay, so as earlier I've put all of my commands. The commands are essentially same as the previous example. I have the same Atmega, same motor drivers, the same motor, the same nodes, everything connected accordingly. The only difference is instead of having a digital input on pin 19 or node 18, I have a sinusoidal input. This is 10 on pin number on node number 96. Okay, let's simulate this for 5 seconds. We want to plot the motor speed, not any of the other signals, just for clarity. And okay, now let's run the simulation. So running these simulations is again as simple as this, running this particular Python script. And as we run that, this might again take some time because we have really small time divisions. You can increase those time divisions in order to get a much faster simulation. Okay, so this is the motor's response. As you can see, the speed is varying sinusoid and our input signal was a sinusoid, so we get the response as expected. Okay, so now we can do a lot more with this. Instead of just plotting the speed, we can also plot the PWM signals that we are getting from the microcontroller. So in order to plot those, what I will do is I will plot these. Pin 23 and 24 are the PWM pins, and node 96 where we applied the input sinusoid. We don't need, since we are not seeing much, so we simulate it just for 1 second to. Okay, now we run this script. Okay, so what we have, it's nothing's clear because it's just a lot of voltages going from 0 to 5 and back at a very high frequency, so you can't see much here. But if we magnify this, oh, you can see magnified it too much, so Okay, let's magnify it a little less. Oh, it's still too much. I mean, as you can see, there's sinusoidal signals and there is an input signal that is rising. This is really a part of the sinusoid. So in order to get a slightly better view, what we will do is, so we get more voltage variations, I'll increase the frequency, reduce the simulation time, and then plot the same stuff. If I run it now, yeah, this is much better. Yeah, as you can see, this is the input sinusoid and these are the PWM signals, and here when it's the PWM signal is rising, the pulse width of the PWM signals is increasing. At here it achieves a maxima where the sinusoid peaks, and then as the sinusoid starts to decrease, the input signal starts to decrease and the PWM duty cycle or the pulse width starts to decrease, and where you see here it's very low because the sinusoid has hit a minimum. So this input sinusoid the MCU will vary the PWM pulse widths according to the sinusoid, and then that will cause the motor speed to change. And this entire system with an input signal, some sinusoid, some drivers, you are able to simulate this entire system in tessim with the exact same binaries that we can upload on the microcontrollers target directly. Okay, that's all for this demonstration, and thank you.